So another example that I want to now teach from is the following compound, which has multiple resonance structures, right? And resonance I've talked about with some of you individually. We did not get to it in the last group session, so let me formally define it here. Resonance is pi electron delocalization. And pi electron delocalization, right? Pi electrons are housed in p orbitals. And to have a p orbital, the atom must be sp2 or sp hybridized, okay? Not sp3, because in that case, all the p orbitals were hybridized together upon bonding. Delocalization means the spreading out of among multiple atoms or moving electrons around. Okay, so let me draw some resonance forms here, and then we'll talk about some general rules for doing so and how we then assess what the real molecule or the hybrid looks like. So this is resonance structure A. The first thing I do is I go through and look at some hybridizations, right? So if we put sp3 carbons in orange, the carbons that are only singly bound, these have 4 domains, so they're all sp3 hybridized. The carbons that are doubly bound are sp2 hybridized. Okay. This